Chapter 3, Exercise 25. Part A, assume that G is a one-to-one function. Show that G composed with G inverse is I ran G, the identity function on the range of G. Part B, show that the result of Part A holds for any function G, not necessarily one-to-one. Okay, so first of all, I just want to make an observation. And it might be obvious, but Part B implies Part A, right? If we prove it for all functions, then we also prove it for all one-to-one functions. And I think the important part of this, and why I want to point it out, is that I don't know about you, but I can't be arsed to do the same proof twice. So I'm just going to do the proof for Part B, then appeal to this, and leave it at that. So with that said, we're going to show that for any function G, G composed of G inverse is equal to I sub range of G. Okay, so let's assume G is a function, right? Then G is a single valued relation. This just might be overkill, but it's just good to know. Okay, now let's actually get on with the proof. Let's suppose some pair x comma y is in G composed G inverse, right? Now since this pair is in the composition of two functions, then there exists some t such that x comma t is in G inverse and t comma y is in G. Now note that x comma t is in G inverse if and only if t comma x is in G, right? So we have that t comma y is in G and t comma x is in G, but G is single valued, right? So what does this mean? G of t equals x and G of t equals y. So the only thing we can actually say is that x is equal to y, right? Cool. Thus x comma y is equal to x comma x, which is equal to y comma y. Alright, so it's just an important fact that we'll use pretty soon. Now note that since t comma y is in G, then y comma y must be in the identity, the range of G, right? And then finally, since y comma y is the same thing as x comma y, then not this, x comma y is an I sub ran G. And since this was the element we started out with, it follows that G composed of G inverse must be a subset of I sub ran G. Cool. And now to do this backwards, let's suppose that y comma y is an I sub ran G. Then y must be in the range of G. And then since y is in the range of G, there exists some x such that x comma y is in G, right? And then x comma y is in G if and only if y comma x is in G inverse, right? So we have that y comma x is in G inverse and x comma y is in G. So here you can see that we can link this y and this y via this x. So y comma y is in G composed with G inverse, and thus I sub ran G must be a subset of G composed G inverse. Finally, last thing left to do is to, as usual, conclude that G composed G inverse is actually equal to I sub ran G. And there you go. We proved part B, which in turn proves part A, and we are done. I hope this was helpful, and I'll see you in the next video. Bye-bye.